Alrighty, so today we're going to be having a little bit more of a detailed look at reducing balance depreciation using geometric sequences. So a company establishes a computer server at a cost of $80,000 in 2015. The company accountant decides to use the reducing balance method at a rate of 25% to calculate annual depreciation. So that's the annual depreciation. And because we're doing depreciation, R is going to be equal to 1 minus I, where I in this case is going to be 0.25, the 25%. Now, just as a reminder, we always have our A naught, our value at 0 to start with. So, and hence the value of the server each year until its value declines to less than $5,000, at which point it will be written off. So we're waiting until AN, the value of it, gets below $5,000, at which point it will be written off and scrapped. So it says A, construct a table of values showing the value of the server until it is scrapped, round values to the nearest dollar. Alrighty, so we've got most information. First of all, set up our variables. AN is the value of the server after n years. Alrighty, and we've got AN is equal to A naught R to the N. That's just the T naught form, but with A's instead of T's. And then we can sub in everything we know. We know that A naught is equal to 80,000. 80,000. R is equal to 1 minus 0.25 or 0.75. And we don't know N. We're waiting until AN is equal to 5 or less than, when AN is smaller than $5,000. I'm just using the less than symbol there. You could obviously just write that out. Alrighty, so let's put everything we know into this. AN equals 80,000 times 0.75 to the power of n. Now all we want to do is create basically a table of values. Now I'm going to make a bigger table because what I'm going to do is I'm going to put the working out in my table as well. But over here we're going to have the years, which is just n, and we're going to have A of n over here, which is the value, which is A of n. Alrighty, so we've got after 0 years, after 1 year, etc., etc. Alrighty, now I don't know how long this table is going to be. I'm going to start with just the first 4 years, and we're going to see where we go. Now I already know the initial value, that's just $80,000. Now for the first year, that's going to be A1 is equal to $80,000 times 0.75 to the power of 1. And that's equal to $60,000, which is still bigger than 5,000. So we repeat. And this time, I'm going to work at A2. Same, except to the power of 2. So the only thing I'm changing is the power. This time I get 45,000, which is still bigger than 5,000. Continuing on, let's try the third term. And 3, 33,750. Repeating again, 25,312.5. Okay, now at this point, you're probably wondering, this is really cumbersome to use this formula every single time. Although we're only changing one number, it's a bit annoying. So the advantage to do instead is to use a recursive rule. And the recursive rule is basically multiply by 0.75 to get to the next one, right? That's all the way down. And in fact, that's the easier way to do it. And if you just set up your value, click equals, and then just go enter times 0.75, then it is going to generate the rest of the terms for you. So 5, 6, 7, 8, and we'll see how long it takes. So for 5, it's 18,984. Let me fix up my table. The next value, oh sorry, I didn't round that previous one properly. It was 0.38. The next one is $14,238.28. Repeating again, we get $10,678.71. Repeating again, we get $8,009.03. And it looks like I need to go even one step further. Oh, 2 more steps. So let's fill in this table a bit more. So the 9th term is $6,006.77. And finally, the first one under is $4,505.08. So the answer to the question is it takes... it says round values to the nearest dollar. So I'm going to do some rounding. I'll be back in a second. Alrighty, now that I've rounded everything to the nearest dollar, let's just fix things up a little bit. And so we can now say that it takes 10 years for that to happen. B, it says calculate the depreciation amount in each of the first 5 years. Round amounts to the nearest dollar. Alrighty, so let's actually see how much it changes. So the depreciation amount's the amount of actual dollars it goes down, because each time it's just a decrease of 75%. We know that. But the question is, what's the depreciation? How much is it actually depreciation? This is for part B. So the depreciation amount doesn't matter for the first one. There won't be a depreciation for the 0th term. I'm going to give myself a little bit more space. So in order to work out the depreciation amount, and we don't need to do it for everything, we're only doing it for the first 5 years, so we're going up to here. And the thing with the depreciation is it's the actual amount that it's changed by. First thing, we're not using this one, that one's out. So the first amount of depreciation, it's the difference between each pair of values. So 80,000 minus 60,000. Which is equal to 20,000. So in the first year, it lost $20,000 of value. Between the next 2 years, well, this time it only lost $15,000. And in fact, this pattern is going to continue, where when you're using depreciation like so, that the actual amount that it loses each year goes down over time. Unlike compound interest, depreciating things via this method is actually in your benefit. And the last one, we've got 2 more of these to go. I might just do that off camera. So you can see by depreciating things using the depreciation, the reducing balance version, that each step the actual difference goes down. So the amount it actually loses goes down over time, which can often be in the advantage of the owner of the thing. Alrighty, I'll see you in the next one. Goodbye.